Hello everyone, and welcome to the Canadian Electricity Association's Conversation webinar series. My name is Farhan Mirza, and I am pleased to be your host for today's session. I would like to begin by acknowledging that the land on which I'm broadcasting you from today is the traditional unceded territory of the Algonquin Anishinaabe people. The Algonquin peoples have lived on this land since time immemorial. I'm grateful to have the opportunity to be present in this territory. I'd also like to recognize Canada as the land of the First Peoples, Inuit and Métis. I'd like to pay homage to the Indigenous peoples past, present, and future that continue to work, educate, and contribute to the strength of our country. I would like to recognize that this land is shared through historic treaties, developed through contemporary treaties, and one that continues to be unceded territories. The Conversation series features presentations from CEA's corporate partners, and the series will highlight a variety of Canadian and international solutions to current and future challenges faced by our industry. Working with CEA's corporate partners, these webinars have been developed to be of specific interest to those working in the electric utility space from generation through to the customer. For a list of upcoming sessions, please check out CEA's website at electricity.ca. Just before we get going, I'd like to go over a few housekeeping items. Our session today is scheduled to run from 1 to 2 p.m. Eastern Standard Time. Questions can be asked, and we'd encourage you to do so as they come to mind by typing them to the chat function on your screen. They will be asked at the end of the presentation. Also, a brief survey will be sent out to webinar participants following the session today. We very much appreciate your candid feedback and are interested in any topics you'd like to have included in the conversation series in the future. Please keep an eye out for future webinars and events through CEA's monthly newsletter, Current Affairs. With over 6,000 subscribers, Current Affairs, much like the national newspaper, is the place to go for Canadian industry news as we connect the national value chain from generation to the customer. If you would like to receive Current Affairs, you can subscribe to this free publication by CEA's website, again, at electricity.ca. Moving over to today's session, we'd like to welcome NISUS Corporation, who's going to be presenting on copper naphthenate, how the leading replacement for pentachlorophenol improves ESG and sustainability.
Thank you, everybody, for joining us this afternoon. My name is Jeff Lloyd, and I'm the Senior Vice President of Innovation and Sustainability for NISUS Corporation. I'm very happy to be here. 3 important points that you might consider as a utility with regard to what we're going to be talking about today. NISUS Corporation is a chemical manufacturer that produces preservatives. We try and focus on improving environmental profiles and reducing human health impacts. We're very focused on utility pole sustainability. And this includes product life, extending product life, reducing cost, improving worker safety, improving environmental performance, and even having better end-life options. End-life is really a very important feature that we look at when we look at utility poles and other wood components today. NISUS Corporation provides a depth of knowledge to utilities in several important areas. And we have access to many PhD level scientists, both at our company, NISUS Corporation, but also experts around the world in various associations and research groups. The discussion topics today include the status and use of pentachlorophenol in Canada. We'll look at copper naphthenate, some basics, some environmental health and safety components, the very important efficacy data for copper naphthenate, including that produced in Canada, end-of-life options that I mentioned, and who's currently using copper naphthenate and where you might get copper naphthenate utility poles from. Health Canada, PMRA, has currently announced they propose to eliminate the uses of pentachlorophenol. This is really based on a couple of different things. First of all, it's recognized that pentachlorophenol itself is a carcinogen, but it's also listed as a persistent organic pollutant under the Stockholm Convention. And both Canada, that uses pentachlorophenol today for utility poles, and Mexico, where pentachlorophenol is manufactured, are both signatories of the Stockholm Convention and so have to cease using pentachlorophenol in the future. The final decision is likely to be announced at the end of this year. And since penta is a carcinogen, as I mentioned, it's very likely to be eliminated. We expect that PMRA in Canada will follow the US EPA timeline. The United States Environmental Protection Agency is also planning on eliminating the uses for pentachlorophenol, And as you may know, I think all other countries in the world have eliminated the uses of pentachlorophenol, and even many years ago, even decades ago, for the Europeans, for example. With regard to continued uses, we expect the cancellation to be announced at the end of the year, but we expect there'll probably be 2 years given to work through inventories. Although in the US already utilities are rapidly switching away from pentachlorophenol because they don't want potential ongoing liability of using a material which is recognized in this way and has essentially been restricted from use. The leading replacement for pentachlorophenol globally really, but especially in the United States, is oil-borne copper, and specifically copper naphthenate. And NISUS Corporation is a primary registrant and a primary manufacturer of copper naphthenate. Our facility, seen here, is based in Rockford, Tennessee, in the United States. And we manufacture product and ship it all over the United States and all over the world. As I mentioned previously, we try and focus on the environment, the economy, and human and social aspects. And these are really our 3 legs of sustainability. We'll talk about these as we kind of move through the program. I mentioned the scientific acumen we had at NISUS Corporation already with our various PhD and other experts in the area of wood science and wood protection, and that includes mycology, microbiology, and entomology. We have industry-leading research with many papers published every year in research journals. And everything I'll talk about today, all of the scientific data, all of the performance data, has been peer-reviewed published. So if you'd like more information on that, please reach out to us, and we would be happy to forward you the research papers, etc. Especially end-of-use planning and recycling is a big area of interest, and we get a lot of inquiries from utilities about that. We have cooperation with major universities in North America and around the world, and right now we have field tests running at approximately 10 different field stations at universities and research groups around the world, and we'll look at some of that data today. We have an in-depth knowledge at treatment plants, and Ken Lachlan, he's our Vice President of Sales. He actually has run a number of treatment plants throughout his career and was responsible for the $75 million plant in the Pacific Northwest, and currently works for NISUS Corporation. We're very pleased to have him aboard, and he's worked with us for a number of years now. Our regulatory department also works very closely with federal, state, local and other government agencies and other national agencies, and we try and keep utilities abreast of pending regulations and things that may impact them generally. Let's have a look now at copper naphthenate. I've mentioned its use as a treatment product for utility poles, but of course treatment is also carried out for cross arms, and you can see cross arms there in the top left box. I'll touch on the color again for copper naphthenate. You can see here the color is a sort of an olive brown color. It's a very nice natural color, and the wood itself after treatment comes out of the treatment cylinder very dry, so it doesn't bleed and has no surface residue aspects, which you may be familiar with other preservative systems. Copper naphthenate we actually manufacture by taking natural naphthenic acids, organic acids, and we react those with recycled copper, and the copper and the naphthenic acid together makes an oil-soluble copper. The copper is not water-soluble, and it's not conductive to electricity, so it's not immediately what you would think of when you think about copper products. It's an oil-borne copper material. Here we can see some utility poles treated with the 4 major heavy-duty wood preservative systems. We have creosote on the left, which is a black type product. Then we have the copper naphthenate, that olive green, olive brown color I mentioned.
Then pentachlorophenol, that's the material that's going away. And then the waterborne product, chromated copper arsenic, they're shown on the right. Here's just a diagram of the naphthenic acid that's used compared with acetic acid or vinegar down here at the bottom. You can see this double bond oxygen is the acidic group, and all we're doing is adding a bigger R group, if you like, more carbon on the end to make it oil soluble, as I mentioned. We do this in large scale reactors at NISUS Corporation, and this is one of our 2 current reactors, and we have a 3rd one being built at the moment. We also have manufacturing capability currently in the state of Georgia and in the country of Belgium, and we like to have backup manufacturing capabilities in case of a natural disaster or something like that, so we can guarantee reliability of supply. Here we can see one of my colleagues, Carson, and she's carrying out some copper titration. We carry out all our QC analysis using X-ray fluorescence, titration, and also inductively coupled plasma argon emission spectroscopy. So we've got lots of different ways of analyzing the materials to make sure our customers get quality products and to make sure utilities can check at any time that their treated materials have been treated correctly and will give the performance that's expected. Why use copper naphthenate protected wood? Well, there's a whole host of reasons here. First and foremost, potentially, copper naphthenate is considered safe enough for retail use. And in the US, it's actually listed as a non-restricted wood preservative as opposed to a restricted use pesticide, which pentachlorophenol certainly is listed as a restricted use pesticide. But it's a very clean end-use product. It's the least leachable material, so it has the least amount of potential environmental impact. It treats both Douglas fir and pine, and that's very important, especially in Canada, where you like to use a lot of Douglas fir, which is a more difficult to treat wood species and produces the larger pole sizes. It actually works better than the alternatives in about every measurable characteristic that might be of interest to you, and we'll look at those in a little bit. That includes good lubricating and waterproofing qualities, as well as being non-conductive and giving better GAFF penetration. So it's very easy to climb the poles in the field if you haven't got a man lift option. Good end of life options, as I mentioned, and really it's the only proven cost-effective replacement for pentachlorophenol. There is efficacy data lasting for more than 100 years for copper naphthenate, and we'll look at that here in a bit, with proven safety and efficacy over a very long period of time. So it's really very well tried and tested. Switching over to health and the environment now. This is a diagrammatic representation of the various classifications and government restrictions. You don't really need to pay a lot of attention to the various categories. It's just to show you that, relatively speaking, copper naphthenate has a very small health and safety and environmental footprint, especially compared with pentachlorophenol. So you can see that copper naphthenate is really much nicer to work with and much nicer to use, both from a worker standpoint as well as from an environmental standpoint. Here's a table of the same information, just so you can kind of look at those different characteristics. And why this is important is really because wood is such a fantastic material. Wood actually has the lowest environmental impact and is the best product to use for utility poles. We can see that here when we compare wood poles to concrete, steel, fiber reinforced poles. The wood outperforms all of the alternatives in every category. Really, wood is a fantastic material, so it makes sense to use the best environmentally performing preservative system on the best environmentally performing utility pole. With regard to regulatory status specifically, in the various countries, the copper naphthenate is fully registered and has recently passed the re-registration process in the United States. So in the USA now, it's set for at least the next 15 years. Copper naphthenate is also registered in Canada under PMRA and is currently written into the Canadian standards for utility poles. Now, currently in Canada, it's not registered for actual pressure treatment, but that is pending at PMRA, and we expect that here very shortly. And utilities in Canada currently taking copper naphthenate poles are having those poles treated in the United States and then importing those poles into Canada. I mentioned that pentachlorophenol has already been restricted or banned in other countries around the world. And in Europe, that's especially the case. And in fact, all of the other alternatives that I mentioned have also been restricted in the same way. So chromated copper arsenic was also restricted from use many years ago. And now creosote is under tremendous pressure as well, because it's also considered a carcinogen. Copper naphthenate is currently pending registration in Europe, and there's a number of utilities and railroads in Europe looking at that. So we'll talk about that. I'll show you some pictures of that in a second. Moving on and looking at the performance and efficacy data. Efficacy tests are typically carried out on the small scale side if you want rapid data, and then larger scale size to be more realistic for use, including even with utility poles. Here we can see one of the USDA efficacy tests set up many decades ago with copper naphthenate. And here we can see one with posts. These particular posts are being tested by Doug Crawford. He's long retired now at USDA, but he's testing these posts at the 50-year mark. And if the posts break with a 50-pound, about 25 kilo amount of pressure on the posts, then they're considered to have failed. But if they don't break, then they're still performing well. This data has been summarized here in a graph, and you can see that copper naphthenate outperforms both creosote here and pentachlorophenol here. And this performance is actually with only 1/3 of the standardized specified retention. So really the performance is excellent. It's about the best performing wood preservative system you can use. The data I've shown you so far has been carried out in the United States, but there's also a fantastic study that's being carried out in Canada. This was set up originally by Foreign Tech, now known as FP Innovations. That's used to be the government-sponsored research lab for Canada. I'm sure you guys would know about it better than me. But Rod Sterling, who's a research colleague of mine, he presented a nice paper at the Canadian Wood Preservers Association in 2017, showing the performance of copper naphthenate at the 66-year mark. Those posts are still in that test, and now that test has now been running for 70 years. So really fantastic performance with copper naphthenate in these smaller sections, which is a more aggressive test. Here's a test also carried out in Europe. This is a test against chromated copper arsenic. This is one of the 3 field tests in Sweden, and you can see the copper naphthenate material is outperforming CCA in this test. And rather than go through all of the different efficacy studies, which would be fantastic if you suffered from insomnia, I've just kind of tried to highlight some of the various tests here. And really, I'd just like to point out that there's nearly 1,000 years of cumulative field test data for copper naphthenate, showing that it's a fantastic wood preservative to use and really outperforms most of the alternatives. Those tests are ongoing in many different countries around the world now. Here's just actually a field test in Denmark. And here we can see results from France with termites, both decay fungi and termites in this field test. This is similar to the termite species that you have in Canada, actually. And with the copper naphthenate, you can see that the stakes are completely protected so far in this test. So really, really very nice. And of course, as to be expected. Now moving on and looking towards the end of life options, really when it comes to environmental performance, the longevity is arguably the most important thing. If you can make something last twice as long as something else, the environmental impact is far reduced because you don't have to produce twice as much, if that makes sense. But it's also good to be able to have options for what you do with the material at the end of its design life. And we're really, really in a good position with copper naphthenate on that. So we try to, first of all, reduce. We want to reduce the amount of material by making it last much longer. And we can do that with copper naphthenate. And we want to try and reuse the material for other purposes. And then ultimately, we want to be able to recycle the material. And I'll show you some very good ways of doing that with copper naphthenate treated utility poles. And that's important because what we don't want is for treated wood to end up in landfill. We've got a fantastically environmentally friendly story to tell with wood products, but really we lose a lot of that benefit if we have to put material into landfill. So that's really to be avoided if we can. So we've worked with our customers, and here we can see two, Stella Jones and Malott Wood Preserving, and their boilers at their treatment facilities have been permitted to burn used copper naphthenate treated wood as fuel in their boilers to power the treatment of new utility poles and railway ties, actually, in this case. So that's a great way of recovering the energy from the treated wood. You don't have to burn fossil fuel for the energy production, and you're also able to properly reuse the treated material at its end of life. We also reuse the material, and we can see that here. Copper naphthenate being non-restricted is also labeled here in the US for mulch, landscaping timbers, and we can see in this case used railway ties, copper naphthenate treated railway ties being chipped for mulch production and also being used in landscaping here. Recycle and add value and also really give the best environmental picture. I think we're able to actually gasify the copper naphthenate treated wood for energy. This is actually a research reactor here. This is research that was led by Dr. Nikki Labbe at the Center for Renewable Carbon. And here what we're doing is we're taking copper naphthenate treated utility poles, we're gasifying the material in order to volatilize and recover the copper naphthenate for reuse. Then after that early gasification at lower temperature, we do a full gasification at higher temperature, recover all of the energy from that material and actually make biochar as a byproduct. Biochar is a bit like charcoal. It's permanently sequestered carbon. So the tree, when it was growing, sucked carbon dioxide out of the atmosphere. The utility pole stored the carbon dioxide throughout its life. And then at the end of life, through gasification and biochar production, we're able to permanently sequester that carbon as biochar and then use that in typically agricultural applications. We've also been working on that research as well. So here we can see a gasification plant. This is a commercial one operating in Tennessee. All of the electricity produced runs a local water treatment facility. And this is the biochar being produced from the gasification plant. And then that biochar is used in agriculture. And here we can see the University of Tennessee. They're actually applying it to cropland that has been ruined by flooding. The very sandy silt that's deposited from the flood allows the land to dry out too quickly and allows nutrients to wash out. But the addition of biochar restores that land and makes it good again. And we can see that here with this soybean crop with the added biochar and without the added biochar, you can see the increase in productivity and yield as a result of the biochar use. Really a very nice story. And that biochar in the soil now, again, permanently sequestered carbon. Really a very nice story. I mentioned some of the research we do, and this is just some of the research recently on the recycling and reuse of these types of material and the production of biochar, etc. So looking specifically at poles now, and why you as a utility pole user might be interested, and some of your guys in the field that work with poles might be interested, I'll go through some of the benefits there. I mentioned very easy GAFF penetration and non-conductivity. That's very good BIL, basic insulation load. It's non-corrosive to utility hardware, and treaters can utilize existing processing equipment. So a wood treater that previously has been using pentachlorophenol, it's possible for them to switch out and use copper naphthenate. So you don't have to buy all new processing equipment, etc. So the non-conductivity in the good BIL is also very important for fire performance. You won't get smoldering or afterglow combustion that you can see with some waterborne treatment products, where you can have a small grass fire that will leave just some smoldering secondary combustion in the wood, and 3 days later, if the wind picks up, that pole can reignite and restart another fire, or just slowly burn out over a number of days, as you can see here in this particular example. You would not get that with copper naphthenate. Here we can see a nice GAFF study. Copper naphthenate is the best performing wood preservative system for climbability. This work independently produced by Shoup and Freeman. You can see on all of the different wood species and against all of the common oil-borne preservatives and the waterborne preservatives, copper naphthenate is the best material for GAFF penetration and so easy climbability of the poles. And here's the resistivity data. You can see copper naphthenate has the same conductivity or even slightly less conductivity than completely untreated wood. So a big improvement in performance versus pentachlorophenol, for example. So it's so good, some people must be using it. Well, that is absolutely the case. Here we can see in Europe where they really have run out of all of the other preservative systems now because they're considered too dangerous for use. Both the railroads, here we can see Belgium rail and copper naphthenate ties in track. Here we can see French rail, SNCF on the right hand side, and then the British Telecom, the UK utility and their poles. They're all now using copper naphthenate and trying out copper naphthenate there. But in the US, the use has really been much longer, and so we've got a lot more experience. And it's been independently tested and verified. So New Hampshire Department of Transportation, that's a good example. They did a study on wooden bridges, and they concluded that copper naphthenate was the preferred preservative for use, both because of the lack of bleeding and leaching, so you wouldn't contaminate waterways, and also because of improved performance, so the bridges would last a very long time. That documentation, published material is available if you'd like to look at that. And then in Alaska, the Corps of Engineers, they will only allow copper naphthenate for use over water. And we can see here, there's a copper naphthenate wooden bridge here over this river just beneath the glacier as an example. And then similarly in New York, there's no restriction for copper naphthenate over waterways. And really that's been a major driver for copper naphthenate use. Any areas where you have environmental sensitivity, people have tended to prefer copper naphthenate really for a long time now. But more recently, with the demise of pentachlorophenol, there's been a lot of interest and a lot of uptake now in copper naphthenate. So there's now many utilities around the US using copper naphthenate, and there are now also some utilities using copper naphthenate in Canada. If you're interested in obtaining copper naphthenate utility poles, these are the various companies that can treat with copper naphthenate and ship poles into Canada. And you have my information, and my colleague, Dr. Manning, on the left, and my sales colleagues up here, and I'll also show you then again at the end. So to summarize really everything we've been talking about, wood is a far better material environmentally than non-wood alternatives. So please, whatever you decide to treat with, please specify wooden utility poles. In my opinion, copper naphthenate is the best way to protect wood and is the best way to protect your utility poles. I believe your utility poles will last longer and you'll have more end-of-life options, and there'll be less environmental impact from using a wooden copper naphthenate treated product. It's the best performing material with a very long track record and field test data, and I've tried to show you that today. It has the best physical characteristics for use in the field, the best tox and ecotox profile, and the best end-of-life options. Thank you very much. It's been very nice chatting with you, and hopefully we'll be able to open things up for questions here in a bit, and hopefully Farhan might be able to join us again.
I am indeed back. Sorry about that earlier. Thanks for the presentation, Jeff. That was really excellent and great to see kind of all the uses and applications of QNAP. We've already got a bunch of questions flowing in, so we can get right to them. So to start things off, Jeff, maybe you can talk about a little bit more about QNAP. Is it approved by PMRA for pressure-treated wood power poles?
Yeah, so specifically right now, it is registered for use in Canada for wood, but it is not registered for pressure treatment of poles in Canada. So utilities that are currently using copper naphthenate treated bridges, railway ties, and utility poles, they have the product pressure treated in the US and then they import it into Canada. But we do expect the registration for pressure treatment in Canada to occur very rapidly now. PMRA has had the documents for a number of years and is very actively working on it. So we very much hope that Canadian treaters will be able to treat with this material in the very near future.
Okay, follow-up, since QNAP is not approved by PMRA for wood power poles, are utilities in Canada who are importing QNAP pole breaking the law?
No, they're allowed to import material into Canada because Canada has a treated articles exemption. So provided the product is registered in Canada for use on wood, and copper naphthenate it has full registration for that, you're allowed to pressure treat in the United States, treat the wood, and then you can import the treated wood. And PMRA at quite a senior level has actually written to confirm that that is actually the case, and we would be happy to supply that information if utilities are interested in that. And as I mentioned, utilities are currently using copper naphthenate treated poles in Canada, and we have bridges and railway ties and other things as well.
So a follow-up to that, thanks, Jeff. Why were there lawsuits regarding QNAP in the past?
So I think years ago, you're talking about some premature failures in the southern United States. There was a huge problem with pentachlorophenol under the Celon brand name, and many thousands of pentachlorophenol poles failed. There were a few copper naphthenate poles that purportedly failed, but in actual fact, the material that was supplied by the manufacturer at the time, it wasn't really copper naphthenate, it was another oil-borne copper using a shorter organic acid, and so there were some emulsification issues with one of the problems, but then also they were using air-dried southern yellow pine poles, and nowadays we only kiln dry southern yellow pine for poles because it's recognized that in the southeast United States, where it's very wet and warm, the wood rots very quickly, and if you air dry southern yellow pine, you've already got fungal decay there, and if you try and treat the wood when it's already rotten, it's already too late to try and save it. So yeah,
that's fair. Is there a warranty for the treated wood power pole like CCA or DCOI offers?
Yeah, so currently we don't have a warranty. We've been talking about doing a 65-year warranty, along the lines of our efficacy data, which has been independently produced. But the warranties for CCA and DCOI aren't really worth much. If you really read into it in a lot of details, it's not really very meaningful. And so we felt that so far it hasn't been necessary to have a warranty. But if we were to do a warranty, we would run along the lines of our efficacy data that's been independently produced in Canada and in the USA, and that would probably be 65 years.
Excellent. Okay, these are great questions coming in from our audience. So why does QNAP leach less than Penta?
Okay, well, a couple of reasons. First of all, the amount of copper that's present in the wood is much lower than the amount of pentachlorophenol in the wood. The efficacy level is better. And so leaching, the opposite side of the same coin is diffusion, and for diffusion occur, you need concentration. But also, after you've put the copper naphthenate into the wood, the copper tends to react chemically with the wood and grab the wood as well, whereas the pentachlorophenol only stays solubilized in the oil, and as the oil can run down the pole and even out of the pole, oftentimes with Penta you have to put too much oil in the wood, the pentachlorophenol will run out of the pole. It's called bleeding, and that contributes to leaching, whereas that tends not to happen with copper naphthenate, and the copper naphthenate is tightly bound to the wood, as well as starting off being only oil soluble. And that's reflected if you look at the EPA leaching data, for example. There is data lodged with EPA and also with the American Wood Protectors Association, and you can see that copper naphthenate is the best performing material with regard to leaching in both of those data sets.
Excellent, thank you. He's a follow-up from that. So the leaching studies is for the QNAP and not the oil, is that correct?
Yeah, that's correct. Yeah, typically what's done with copper naphthenate is we look for the copper when we look at leaching studies, but you can do leaching, you can look for the oil as well. Typically what we try and do is we do a hot process, a hot treatment, and we try and minimize the amount of oil that's used so that to try and avoid dripping and bleeding, and that happens with other preservative systems. And I think that's been well recognized by, for example, the Corps of Engineers in Alaska and that New Hampshire Department of Transportation. They both went with copper naphthenate bridge systems because they're not dripping into the waterways all the time.
Excellent, thank you. All right, next question. What regulations exist in Canada regarding regarding use directly in or near wetlands, not just over water as in bridges?
Yeah, so with regard to specific regulation in Canada, I'm not too sure. The registration normally for copper naphthenate, that's the preferred material for use, but we don't use copper naphthenate for marine uses. So freshwater, lakes, reservoirs, wetlands, things like that, copper naphthenate is the best material to use because it's the least leachable. But we don't use it at all for marine pilings, for example.
I see. Okay, excellent. So one of our utilities says that they typically use cedar for utility poles. Are you able to treat cedar effectively with QNAP?
Yes, so we do treat cedar a lot with copper naphthenate, and with cedar we can do an entire pole treatment, or we can also do what's called a thermal butt treatment. So in colder climates like Canada, where you've got a slightly lower insect hazard and you use a naturally durable wood species like cedar, it's possible to only treat the part of the pole that's going to go in the ground, and the part of the pole that stays above ground, it's possible to leave that untreated and rely on the natural durability if you wish. So we have the option of either treating the whole pole with a traditional pressure treatment, or doing what's called a thermal butt treatment and only treating the part that goes in the ground.
Excellent.
That's really specific for cedar, and we don't normally do that for other species of wood at all.
Okay. Is anyone that you know of using poles that are butt treated only with QNAP?
Yeah, I think that thermal butt treatment is carried out in the USA. I don't know if anybody's doing that in Canada.
Okay. Are treatment maintenance procedures like boron injections necessary?
So with regard to CEDA, typically not, because, well, when you do a traditional pressure treatment, you're typically treating the sapwood of the pole and not the heartwood. The bit that's dead in the middle of the tree is more durable. And with Douglas fir, which has a very large heartwood that isn't super durable, it's often very good to do remedial type treatments of that heartwood. So it's very common practice to do that, especially with Douglas fir. With cedar, you've treated the sapwood well, but you've got a naturally durable heartwood, so you typically don't do that with cedar. And we actually get very good results with boron, as an example, with copper naphthenate. The two materials are synergistic. So if you do a liquid boron application into the heartwood of Douglas fir, maybe at 15 years or 20 years or 30 years into the life of the pole, that will really stop any decay or insect damage in that heartwood. The copper naphthenate is still performing, obviously, in the sapwood, and that can significantly extend the life of the pole. I saw some recent data whereby if you carry out good pole inspection and good pole remediation, it typically adds about 20 years to the total life of the pole. Yeah, so that's a good thing to do.
Excellent, thank you. Have there been any assessments for soil contamination around QNAP treated poles?
Yes, there have. There have been some very good published studies. One by Brooks, for example, is one that immediately springs to mind, and that's some of the data that I'm using when I'm suggesting that copper naphthenate is also the least leachable wood preservative system.
Okay.
Yeah, I'm happy to make that available if somebody wants to contact us for that report as well.
Sure, yeah, we can make those connections. And so further concerns about the environmental impact of QNAP. So maybe can you elaborate on that a little bit more?
So I didn't understand the question.
So the environmental impact of the naphthenate on on the environment here in Canada, is there any negative?
Yeah, the environmental performance is really great. It's probably the best for copper naphthenate of any wood preservative system. So, and you're getting a multiple benefits through the use and life. So first of all, the material itself, we utilize recycled copper. So that's a good environmental benefit. Then we extend the life of the pole. The pole typically lasts longer, so you can use less poles potentially over the design life of the product, of the material. So that's a big environmental advantage. Obviously, you've used less wood, you've used less chemical, because you've used less fuel in transportation, etc. You've got less material to worry about end of life. So you've got all those environmental benefits because of the extended life. You've got the least leachable preservative system, so you don't have to worry so much about what chemicals going into the environment. You have no sensitization. Some of the preservative systems that are used, if you regularly touch them with bare skin, they can induce sensitivity over time, and that's something that you don't get with copper naphthenate. So there's just advantages at every turn with copper naphthenate, and really compared to the alternatives, copper naphthenate is by far the best.
So thank you. Just a clarification on that, they mentioned not the environmental impact of QNAP, but more the oil leaching off the pole. There's a difference.
So yeah, for the oil leaching off the pole, that's typically a process we call slumping in the industry, and that's a big problem with traditionally it's been a big problem with both creosote and with copper naphthenate. The total oil loadings tend to be a bit higher with those, and as I mentioned, copper naphthenate, as I mentioned, pentachlorophenol itself doesn't bind to the wood, so both the oil and the pentachlorophenol itself can kind of trickle down the wood and can then bleed out of the wood at the baseline. With copper naphthenate, we try and treat the wood hot, like I mentioned, and the gross retention of oil is less. So because of that, if in those previous pictures I showed you, you saw the wood was completely dry to the touch, immediately out of the pressure cylinder. I mean, it comes out of fresh from treatment in hot oil, the wood comes out dry to the touch. So it's not something that you expect to see bleeding or slumping, and best management practices are specifically designed to reduce bleeding in preservative treatments anyway. And copper naphthenate, I think, is about the best one, or the least leachable.
Least leachable. Okay, got it. Yeah. Jeff, you mentioned earlier that premature pole failures in the southern U.S. You were talking about those. Was the manufacturing process changed or altered in any way?
Yeah, so the manufacturing process wasn't, but the original EPA registration and the AWPA standards, they were actually breached. The manufacturer at the time making that copper naphthenate, instead of using naphthenic acid, so it's called copper naphthenate, so you use the natural organic acids, naphthenic acids, they actually used a really cheap organic acid, and it's a much smaller organic acid. And so the copper itself, the copper and the organic acid, was not only oil soluble, it was also a little bit water soluble. So with that type of a system, you can get increased leaching, you can get emulsification where the oil in the treatment cylinder can hold water. So you're trying to pump the oil and chemical into the wood, but you're also pumping water into the wood. And as I also mentioned, the wood itself was air seasoned southern yellow pine, so it was already partially rotted. There were a few companies involved in that at the time. We're talking maybe 30 years ago now, and NISUS Corporation was not one of them. NISUS Corporation does not make its product in that way, and NISUS Corporation does very strictly adhere to both EPA in the US and PMRA in Canada registration requirements. We have to do that. That's a legal requirement. We're not allowed to make things up as we go along. It's very, very strict and very regulated, of course. And we also very much follow the AWPA standards and the Canadian Wood Protection Association standards as well. So it's a very regulated industry, much more so than it was. And the problems at the time are really not to be associated with copper naphthenate. It wasn't copper naphthenate that was being used.
Got it. So you were talking about that time frame. In that same period, was all of the QNAP problematic, or was it just from a certain pole treater?
It was specifically from a chemical supplier, and there were 3 copper naphthenate chemical suppliers at the time, and I think the one in question was called OMG. They were the manufacturer that was, in my opinion, cheating and not manufacturing the material appropriately to both the EPA requirements nor the AWPA standards.
Understood. Will suppliers be required to use different treatment processes for QNAP compared to Penta and CCA? And second part to that is, does the QNAP process add any time to the manufacturing process?
Yeah, very good questions. Well, CCA is typically applied to very dry wood, so you normally use kiln-dried pine. You wouldn't use CCA, nor could you on Douglas fir. It doesn't treat very well at all. Copper naphthenate can be applied to kiln-dried pine in exactly the same way as CCA can, but typically we like to do it hot. It doesn't have to be hot, but you end up with a faster, easier process. The oil is thinner when it's warm. Does that make sense? It's less viscous, so it's easier to treat the wood when it's hot, and we end up with a very dry, clean product when we do it hot, so we like to do that. With regard to Douglas fir, we can do that dry on Douglas fir with the wood already being dry, but we can also treat green Douglas fir when it's still naturally wet from when you cut the tree. And what we do there is we boil the wood in the oil to drive out the water to make it dry to then put in the chemical. That's a process called Boltonizing or Bolton drying. And so with copper naphthenate, we can do a process that's very different to CCA, or we can do essentially the same process as CCA if we're treating pine. But with Douglas fir, we've got the two options. Same with cedar. We can Boltonize cedar, or we can treat dry cedar, or we can do that thermal butt treatment, and you wouldn't do any of those with CCA either.
Excellent, Jeff. So we have another question here. So if pressure treatment is not an approved application in Canada for copper naphthenate, do you feel it undermines the regulatory process here?
Yeah, so I don't think it undermines the regulatory process, because it's the Canadian process, and they've set it up to be like that. Most countries in the world have a treated articles exemption where you can do exactly that same thing, and Canada's is actually a bit more difficult than most other countries. Actually, in Canada, you can treat wood with anything and import it into the US under the treated articles exemption. So, but I also think that by the end of this year, we should have approval to pressure treat in Canada. What we'd very much like to do that. The thing that rubs me the wrong way really is not the regulatory process so much, but just Canadian jobs. I think that Canadian wood treaters should be able to use the greenest preservative available. They shouldn't have to be exposed to carcinogenic persistent organic pollutants, and frankly, they shouldn't have their jobs taken by American workers. It would be very good to treat Canadian wood in Canada by Canadian workers, and that's really very much what we'd like to see.
Awesome, that's great, thanks. All right, one more question, I think. Are there utilities in the US that have QNAP treated poles that have been in service for over 40 years?
Yes, we have utilities in the US with poles in service for in excess of 65 years, actually, maybe even 70 years now, so very long track record. Copper naphthenate was actually invented in about 1913 in Europe, so it's a very long, very tried and tested preservative. And there are Douglas fir utility poles that have been in service for a very long time in the US, at least 65 that I know of for fact.
Oh, awesome, thanks. How long have QNAP poles been used for utility poles? Has it been that long?
Yeah. So I would say on and off for probably 100 years. And they were used very extensive. Copper naphthenate was used very extensively during the Second World War, for example, when there wasn't enough creosote, and so copper naphthenate was used as a creosote extender. You would mix creosote with oil and add some copper naphthenate, and that was used to treat both utility poles and railway ties at the time, because there wasn't enough creosote to go round. So lots of different uses of copper naphthenate. And you would probably remember, you're probably not old enough yourself, but some of us more grey-haired folks, the green army tents or the green Boy Scout tents with that very slightly odor that you might remember as a kid, or if you're in the army, that was actually copper naphthenate treated material. So also canvas and rope and things like that treated with copper naphthenate over the years. So yeah, lots of experience, and obviously very low mammalian toxicity and environmentally friendly to have Boy Scout tents treated with copper naphthenate.
Very nice. So you mentioned creosote, Jeff. Could they use creosote poles if they wanted to?
Yeah, so creosote is a very good wood preservative, tried and tested. There are some health and safety issues associated with creosote though, so I would suggest that it would be better to use copper naphthenate. If you did decide to use creosote, it's probably better to use that on pine. It's easier to treat pine than Douglas fir, and I wouldn't choose creosote to treat Douglas fir. Douglas fir doesn't treat as well with creosote as it does with copper naphthenate.
Okay, can you talk about the timeline of usage for QNAP for yellow pine? You just mentioned pine.
Southern yellow pine? Yeah, so I'm less experienced with southern yellow pine, and traditionally copper naphthenate has been used much more with Douglas fir, because you can't treat it with some of the cheaper nasty preservative systems. So Douglas fir is a bit more, it's more refractory, so it's harder to treat, so really needs an oil-borne preservative like copper naphthenate. But copper naphthenate is in the standards for southern yellow pine, and it is actively used for southern yellow pine treatment, and that's been especially the case for bridge timbers. So NISUS Corporation, we've been manufacturing copper naphthenate for in excess of 10 years now. And since that time, some of the first uses were for southern yellow pine bridge ties and southern yellow pine bridges, as well as Douglas fir bridges, of course, because of the cleanliness and the environmentally friendliness. With regard to poles, copper naphthenate can be used for poles. It is used for poles, but I don't know of any very long-term use like with the Douglas fir.
Okay, perfect. Last couple of questions, and then we are almost at time. So, first one: how long do you think Penta will be around realistically?
Yeah, so pentachlorophenol, I believe, will have a 2-year period of time to use up chemical. And then if there's still wooden poles in stock, I think they'll be able to be used thereafter that. But the big question is, will utilities decide to continue to use pentachlorophenol? I think that once the registration has been cancelled by PMRA or in the US by the US EPA, utilities will decide there and then they will no longer use pentachlorophenol just because of potential liability. You know, why would you choose to use something that your government's regulatory agencies have told everybody it's too dangerous for that use? So my personal opinion is that instead of that 2 + 2 year period or 2 + 3 year period, I actually think it's going to go very quickly. And if you remember the slide I showed you earlier, all of those utilities using copper naphthenate, half of those at least have occurred in the last year because of the demise of pentachlorophenol. I mean, those utilities weren't using copper naphthenate 10 years ago. They're converting to copper naphthenate very quickly now because of the issues with pentachlorophenol.
Excellent. So lastly, we'll end on this. So will QNAP manufacturers have the ability to increase production when Penta leaves? So one of our members is kind of referencing a study that says Penta was about 56% of the pole plant market in 2004, according to a study. So is there the ability to increase that?
Yeah, so currently at NISUS Corporation, we have enough capacity to be able to supply the entire utility pole market, but we also are seeing growth in the railway tie market as well. So we're actually adding, we've been in manufacturing production for a period of time. Like I said, we've already added a second reactor to double our capacity, and we're now adding a third. In addition to that, we do have contract capability. We don't own the plant, but we're contracted to use it if we wish, out of the state of Tennessee, and also in Europe currently. So if demand did spike very quickly for us, we would actually potentially manufacture at those sites as well to meet demand. And you know, so I don't think that we're terribly concerned about meeting the need, although that would be a nice problem to have, wouldn't it?
That'd be a good problem to have, yeah.
Yeah. I should also say, in addition to that, copper naphthenate is not protected by patent. It's been around for a very long time. Anybody can make it, and actually, Koppers has already announced they will manufacture copper naphthenate as well. They're a competitor of ours. And they already have a copper naphthenate registration as well. So NISUS Corporation shouldn't be considered as the only manufacturer of copper naphthenate. There'll be other manufacturers as well, and there are many treatment plants treating with it. So it's very easy for utilities to get competitive bids, etc., which I think they like. So I think other manufacturers for copper naphthenate will also potentially help out with capacity.
Excellent, perfect. Thank you for that clarification. And Jeff, thank you so much for taking the time to answer those questions. That was really great engagement from our audience, so we appreciate that as well. We'll have to wrap up now as we are at time. So thank you to NISUS for taking the time to join us, and Jeff for your presentation. We've posted all the CEA's featured events in the chat, so please go and take a look at those when you have a moment. Other than that, thank you much for joining us, and we'll see you at the next one. Stay safe, and bye for now.
Very good. Thank you. Bye-bye.